This is a great experience. It combines that little kid's joy of exploration, of maybe seeing something that no one else has seen, with working with a team of fabulous experts and scientists. And you get to do something that very few people have the opportunity to really go experience.
My name is Kirsten Meyer-Kaiser. I work in the biology department at Hole Oceanographic Institution. I'm a marine biologist, and on this cruise, we're investigating a number of shipwrecks and natural hard-bottom sites in the Gulf of Mexico.
We're out here because science-based decision-making is the backbone of the Bureau of Ocean Energy Management. So our job here is to come and take a look at an area of the Gulf of Mexico that our agency didn't have a lot of observations in.
The entire motivation for this project is that nobody really works in the mesophotic zone. So meso is a prefix that means middle, and photic refers to light. So it's the middle light range. In shallow water, there's a generally pretty high level of light, and in the deep sea, it gets down to complete darkness.
So it's not the shallow water and it's not the very deep water, it's sort of the water in between. And so we've been studying biology and shipwrecks in that zone, and it's partly because we don't know much information about it.
It's really easy to do research in the shallow area where you can have scuba divers doing normal recreational dives down to about 40 meters. I'm not going to say easy, but it's also a standard mode of operation to have like a global class research vessel, a deep sea rated ROV. You can go down 200 meters to, in most cases, 6,000 meters. So that leaves a gap between about 40 and 200 meters depth.
Where it's kind of difficult to get information about shipwrecks or biological communities in these water depths. And that sort of information helps us to protect those resources.
So shipwrecks are super cool. They create habitats where there is not supposed to be one. Most of the ocean is sand or mud, so it's soft sediments everywhere. So then there's this hard object that shows up. It's literally a brand new habitat falling out of the sky, landing on the seafloor, and then all of a sudden things can colonize it, like mussels, anemones, sponges, corals. There's usually some fish hanging around.
So we're interested in understanding the biological communities on the shipwrecks and the biological communities on the hard bottoms close to the shipwreck, and the way that they're similar and then dissimilar. We're also interested in creating orthomosaic images of the wrecks.
So photogrammetry is a fantastic tool, especially for underwater interpretation. It gives context in a way that you normally just don't get. And this cruise is a perfect example of that. We have an ROV, it goes down, it's only seeing 1 to 2 meters at a time, but we're on a shipwreck that's 100 meters in length. Well, how do you interpret that? How do you see the big picture? That's where photogrammetry comes in. You take all of these images and you run it through software. It sort of matches points in each image, and at the end, you have a fairly accurate 3D model that lets you see the entire site.
That then we're able to go and dive, map, make images of, play with over and over and over again.
So we're looking at the archaeology and we're looking at the biology. And then we're also looking at the history. We're trying to understand the history of these particular wrecks and how all of those things come together and enhance our understanding of this particular part of the ocean.
We're really taking a holistic view on how these shipwrecks play important roles both in the history as well as current life cycles of ecology and biology.